welcome everybody to the Midsummer July on a Friday night edition of NORA and Oil Tech Talk. I'm my guest host, my co-host, Alan Mercurio. And our guests tonight are Bruce Stowe and Dan Rich of Roth. And we're very happy to have them join us on a Friday evening, which is a new one for us. Hey, Bruce. Hi, Dan. How are you? If you don't mind, can you do a brief intro of yourselves and Roth, what you guys are about?
Yeah. So, Dan Rich, Regional Sales Manager from Long Island down to Virginia. Going on my 5th year at Roth, and loving it so far. And I describe Bruce as the guy that's forgotten more about oil tanks than I'll ever know. So I'll send it over to him now.
Good evening and welcome. Thanks for having us. I'm Bruce Stowe. I'm the Technical and Regulatory Affairs Manager here at Roth North America, which means I get involved with day-to-day support of the marketplace and technical bulletins, technical writing, manuals, some new product development and refinement, and I handle all of our statewide, nationwide product certifications and approvals. So that's, in a nutshell, what I do.
I actually didn't realize until very recently that the tanks were all U.S. made. I still kind of thought they were imported from Germany. So all the tank production is in New York State, USA?
All the tanks that are made for the North American market are made in Watertown, yes.
Okay. That's
yeah, it's been that way. It's been that way since the early 2000s.
2006.
Shows you how much attention I've been paying. That's great. That's great. We always love Made in America.
Yep.
So how about a little history of Roth, the other product lines you have, how you got into the U.S. market?
Yeah, I'll briefly touch on this. So Roth is still a family-owned company, so our shareholders are the Roth family. Bruce and I are employed by Roth North America. We're kind of the American wing of Roth Industries. We make double-wall tanks that we sell to the heating oil and lubricant market. We produce poly septic tanks right in Syracuse, which is where Bruce is now. We have 2 factories. We have the Syracuse factory, which produces the Roth septic tank, and we have the Watertown factory where the DWTs are made, and our corporate office is in Syracuse, where Bruce is in right now. And we also have a line of radiant heating products, tubing, manifolds, design, support that we sell to the commercial, residential, radiant heating, snow melt market. So we have our fingers in a few pies.
A tough question right off the bat. What's the most common problem or issue you see with installations? What are guys doing wrong? What could they do better?
One of the most critical faults that we run across or issues we deal with is using proper methods and materials for the foundation that they put under the tank. And this falls most frequently in the area of outdoor installations. And we're very strict in terms of what we allow for tank foundations. They basically have to be reinforced concrete, either a poured in place slab or pre-cast lintel, structural block basically with steel reinforcement in it. And you can't use patio blocks or generator pads or blacktop or any type of cindered product or placement of the tank and base on compacted gravel or stone or sand or any of that. It has to be on reinforced concrete. And that is consistent. That's our requirement, but it's also consistent with NFPA 31's requirement for liquid fuel tank foundations. So that's probably the biggest issue we run into. And second to that is probably the piping installation for fill and vent requirements. We have our own requirements for pipe diameter and pipe geometry. And those are fairly critical to properly installing the tank and keeping the stress off the tank and controlling the head losses associated with filling the tank.
As far as the installation, problems we see,
that's great.
We experienced 2 guys. I mean, it also starts with the technician reading the manual, right? And I'm sure you experience this with boilers and burners and furnaces and with everything, and we're no different, you know.
Yeah.
Every tank comes with a pamphlet. It's our manual. It's 1/4 inch thick, very specific with rules. Some of them you would think are common sense, and some of the things that Bruce described are unique to Roth, such as our piping geometry, right? But we ask that you just read the book before you install the tank, follow the instructions. If it's an outside installation, make sure you install the Roth tank cover, you know what I mean? Proper foundation, swing joints. I mean, we'll go into all of this in detail, but it does start with reading the book. You guys know what I'm talking about.
Oh, yeah. Who was it, Alan, that had the RTMF license?
RTFM.
Yeah. Read the friggin' manual.
Yeah.
Steve,
Yeah.
I know a lot of guys do it in
was-
their presentations, but I want to give credit to at least what I remember who first started introducing that in their presentations was Steve Wales Wayland. And he would start the presentation because he actually had a license plate, you know, on the front of his pickup truck. And he'd do like his second slide into his presentation.
That is great.
I want to give him the credit, but now I've seen a lot. Jason Mangos uses it. Other guys use it, and there's nothing wrong. I use it verbally. I don't have a slide
I didn't know it
for
was
it.
wheels.
It was wheels.
I can believe that.
and he doesn't say friggin'.
Everything's
Yeah.
It's Friday night. I'm trying to keep it family friendly. So.
But yeah, that's always a good
point
place to
taken,
start.
though.
Yeah,
it's all-
exactly.
One of the things that's worked very well for us
Actually,
along these lines is the
It's common.
certification course that we offer.
I've been to it a couple times. It is very valuable. It's a lot in a short period of time. You got to keep your ears open. But that,
Yeah,
I think that was a great idea to do that when you know you have a product that's a little bit different than what people are used to when you first came in the market. Great. Although, as you mentioned with the foundations, that's NFPA 31 code, so it's common sense. But Steve Martino did have that as one of his questions, and his question was, does it have to be a full poured foundation or a full solid foundation, or can you use lintels? But the lintels are allowed?
Lintels are allowed, but you have to consult the manual if you're not sure what a lintel is. So a lintel is basically like an 8x6 or an 8x4 height and width slabette, if you will, that's the same length or a little bit longer than the crossbars on the base that the tank sits on, and they have to have reinforcing steel in them. So they're significantly different than just a patio block, for example.
Yep.
So
Yep.
we try to reinforce the fact that, you know, people look at a plastic tank with a 19 gauge steel outer assembly and think, yeah, it only weighs a couple of 100 pounds. And when you put 270 gallons of fuel in it, all of a sudden it weighs 2,000 pounds.
Yeah.
And you have to be careful with that. And in terms of liability, that, like I said, is probably the greatest concern and most critical part of an outdoor installation. Indoors, typically you're working on a garage floor or a basement floor, and that structural requirement is already there for your use, basically.
Yeah, makes sense. Tie downs, flood zones. What do you require for that?
We don't have specific requirements for their use. We offer them for use in areas where, and recommend them for use in areas where, you know, you're putting a tank beside a house and there's a stream or water course that runs behind the house. Any situation like that, as we, you know, can turn on the TV and watch in the southern and southeastern part of the country right now, that little stream can turn into something that is a real flood hazard. And so those are good areas to think about tie downs. We also have parts of the country or parts of North America where the prevailing winds are high enough so a tank can get pushed around if it doesn't have an awful lot of fuel in it by wind. So that's another potential application for those.
The only thing really attaching it to the house at that point is a 3/8 oil line. But speaking of the tie downs, if you are in a flood zone, you know, obviously if you are going to tie the tank down, it really can't be tied down to lentils because they're not going to offset the buoyancy of the tank if it wants to float. Okay.
Great.
So if you are in a flood
that's
zone,
correct.
do a cast in place pad, pour a pad, and install the Roth tie down kit. I tell people too, I mean, if you're in a flood zone in a basement, you know, if the homeowner says, yeah, the basement floods every 10, 20 years, set yourself apart, offer to tie it down in the basement. Any tank will become buoyant, right? Steel, plastic, doesn't matter what. So it's bad enough to have a basement flood, but when your tank unloads in the basement as well, due to a Hurricane Floyd or Sandy or Ida, right?
Yeah.
We've all experienced that. Keeps the house much safer and more secure that way. So, yep.
Yeah, actually, Sandy on Long Island is a big thing. So, I mean, there's some rules about, securing tanks on the South Shore of Long Island.
Mm-hmm.
I had actually installed a Roth tank along with a new boiler in a house in Wantagh, very close to the water on the South Shore of Long Island, September 2012, 6 weeks before Sandy. And then, he finally gets the power back on, 2 or 3 weeks after Sandy. And, obviously there's problems. Boiler was flooded, obviously. But the Roth, it was full. He'd gotten a delivery very shortly before the hurricane, and it was still sitting right where it was. His neighbor's oil tanks were all over the lawns and down the block and in the ocean. And there was the Roth sitting there, filled up with salt water in the interstitial space, but perfectly fine and functional. So the homeowner wanted his insurance to buy him a new oil tank. So they refused. They said there's nothing wrong with it. So they contacted you guys and said pump the salt water out and it's still good, no problems.
Yeah. Yep.
He decided to go a different route, but he gave the tank to his neighbor, and to the best of my knowledge, that tank's still there in use. So it survived a hurricane, didn't go anywhere, and it's still 14 years later, it's still out there working.
We need to add that to our literature, Bruce, for hurricane survivors. I mean, anecdotally, there's a customer up on Long Island by you, Bob, that sent me a video. He's an oil contractor, and he's also a volunteer fireman, and he responded to a house fire, and he sent me a video. I'll send it to you and Alan. He was at the house. House was completely gone, okay, burnt down. Chimney was standing, like you see on the news, and the Roth tank was there, and he took his camera. The inside tank melted, but the galvanized steel secondary containment dike held all the oil, and he showed me the video of just the molten bottle inside the tank, but the secondary tank still holding all the oil. It was incredibly impressive. Yeah.
I've seen the same. I don't know if it was the same one or not. This one, the inner tank did not fail. Below the fluid line where the oil was, it didn't melt. It melted above it and kind of like fell in on itself. But the fuel was completely contained in the polyethylene tank. It never even breached it. It melted it where it was dry above the liquid level. But below the liquid level, it was perfectly fine and intact. Very similar. It was a weird. And then he used a saw and cut the plastic out so you could see in it and see the fuel still sitting there, perfectly fine. And the same thing, the house basically burnt almost to the ground. So we've got a comment here from a good friend, Wayne Lawrence. And he says, greetings, very much like the aluminum hardware, great improvement over the composite. Can you give us an update? What's the story with that?
Well, we got to the point probably a year ago here where we're seeing an increase in failure of the not the cap nut that secures the fitting to the top of the tank, but the bulkhead nut that just snugs the inner tank and the metallic tank top together. A lot of those failing. Particularly in outdoor installations, even though they're under the weather cover. We did a fair amount of forensic investigation to see if we had something going on with resin or some sort of difference that there was in the manufacturing process that had changed, and we just really could not isolate what the issue was that was the root cause of the elevated failure rate. So the decision was made to just go away from the molded polyethylene parts and go to metallic parts. So the updated parts are both the bulkhead nut, the lower nut, and the larger cap nut are now made from a zinc aluminum alloy.
I've seen of a couple of them fail, and I think the fuel drivers have a tendency to let the weight of the hose lay on it.
Yeah.
And with the basement tanks, the fill pipe's not properly supported, and they have a lot of leverage, and they're balancing, they're hanging that weight off the end of it. The ones I've seen, I think it's that. Obviously, it could happen for any reason. But anyway, thank you, Wayne. Thank you, Wayne. Nice for the comment.
Yeah, it was the pump drivers hanging their hose, and all the weight of 50-foot long hose, torquing that nipple on the
leverage.
Right. A lot of tension, leverage. And even when the bulkhead nuts failed, it didn't mean that the tank was at risk of having a leak or anything like that. It was still, going to hold the oil in both tanks, but it's still just, after.
It looks awful.
It looks awful and it's scared of homeowners.
Yeah.
Yep. No, makes sense. Wayne has another comment, not a question. Matt Gritman just went over the improvements at their awesome training room. That's your Long Island rep who does a great job here, by the way.
Yes.
I'm sure they all do. But
Matt's a pro.
Yep. So
Matt works for David Gooding Inc. And he was telling me they were having a training there. So kudos to him for sure.
Yep, they do a great job with it. This question, it says me, but it's actually not. It's from Steve Martino. And the question is, what should the fill and vent pipe sizing be? People insist it has to be all 2-inch.
At one point in time, we had changed. There was a period of time in the 2010 to 2012 era when we began to see a lot of tanks that appeared to be overpressured by the filling process. And we became concerned about the pressure drop across the vent alarm itself and also the vent piping. So we kind of, based on the triangulation that we did, we decided that we were going to make vent pipes 2-inch minimum. And there's a lot of, particularly in the Northeast and New England, there's a lot of locations where even the fill pipe was only 1.5 inches or 1.25 inches in some cases. So we toned that back and went to 1.5 inches. So our standard policy now is that in especially with tanks that have any length to the fill and vent pipe network, you should use a minimum of 1.5 inch vent pipe, and the fill pipe can be no larger than the vent pipe. So, but we've recently given a little bit of variance to that, and we will allow 1.25 inch pipe for a vent if the fill is 1.25 inch pipe. And I think the maximum pipe run, lineal pipe run, is 10 feet. If you go beyond that in terms of distance, you're back to 1.5 inches and 1.5 inches minimum. If you have a 2-inch fill pipe, then you should have a 2-inch vent pipe. So all of this is basically intent to handle increasing filling rates that if, people are pumping, typically delivering the oil at higher flow rates than they used to, and just trying to make sure that we don't wind up with overpressure damage to tanks as a result of the accumulated pressure drop in the vent alarm and the vent piping. So that's kind of the story behind it and where we are right at the moment.
Thanks. Supporting, what's the requirements for supporting the fill and vent piping?
Well, I think our guidelines need to be cleared up. They're a little bit confusing. We talk about the requirement for pipe supports and fill and vent piping in indoor applications. If you're fairly close coupled, in other words, if the penetrations in the wall are essentially over the top of the tank or proximal, a short distance away from the top of the tank, then the combination of the grout that will go into the penetrations in the wall, and the fact that there isn't an awful lot of weight that a relatively small length of pipe generates, then you really don't need a pipe support. If you're going to go 10, 12, 15 feet in one direction to get to the penetrations in the wall, then you shouldn't go much beyond 6 feet. I have to confess I can't remember exactly what the distance is, but you should, within 5 to 6 feet of the tank, you should place a hanger in a situation like that to provide support closer to the tank.
Yeah, you see a ton of those in the field, especially when they drilled a bigger hole than you need through the foundation or through the sill. and now you have a 10, 20-foot run, and there's 2-inch black pipe sitting there, and it's got some bounce in it, and they hang the hose off the end of it. Huge amount of leverage.
Yeah.
Yeah.
Or it'll pull in the piping. Yep.
Thank you. Actually, you have another question from Steve Martino. Could you explain the science behind how the twinning kits work for 2 or more tanks tied together? It's a Venturi, am I right? I'll take a guess.
What's that?
It's a Venturi, am I right? That's a guess.
Well, sort of.
Okay.
There's a lot of things that make the expansion kit, as we refer to it, unique, but I'll stick to just the heart of it for trying to keep it concise here. The heart of the expansion kit is embedded in the fill tees, or the fill side of the kit, where you have a tee that is installed in each tank, and then a crossover pipe or manifold pipe that goes in between the tees. The tees are the secret. On the underside of the tee, where it installs in the opening of the tank, there is a significant reduction in flow area. In fact, there's a brass nozzle that's installed in the underside of the tee that's a 1/2 inch in diameter, and it's about 7/8 of an inch long. And there's 2 of those in a 2-tank application, 1 in each tee. And the diameter of that nozzle and the length of that nozzle are exactly the same between the tees. So what this does is it creates a back pressure across that fill manifold, and it ensures that the pressure drop across that nozzle is the same for both tanks. And if the flow area and the pressure drop is the same, then the flow through the orifice will be the same. So that's how you can use an expansion kit to split the flow and fill the tanks evenly. It's all about that flow nozzle or a pressure reduction nozzle in the fill tee, on the bottom side of the fill tee. Because that accelerates the flow the way it does, you can actually induce foaming in the tank, because the fluid will actually flash because of the pressure drop. And we include what we call an anti-foam tube, which installs, it's a drop tube or a dip tube that installs below the fill fitting, just to allow the fluid to slow down and prevent the tank from filling up with foam, which can mess with the operation of the vent alarm and whatnot and give you false signals. So that's kind of the heart of that system. And the whole secret is just making sure that through that reduction nozzle, you're providing the same fill flow to each of the tanks in the multi-tank system.
And I'll add on to that. For that back pressure theory to work, the GPM's got to be at least 40 gallons per minute. Is that correct, Bruce?
It's 40 or 45. Yeah. Some folks are concerned about filling the multiple tank applications or filling through an expansion kit, and they'll adjust their flow setting on the delivery system to a low flow. And that actually works against you, because if you don't have enough flow across each one of those orifices, then you can get unequal pressure drops and unequal filling. So you're actually better off to set your fill adjustments on the delivery system so that you're at full flow, to make sure that you get that equal flow through each orifice.
So you're actually pressurizing the manifold.
Exactly. Yep.
And then both tanks fill at the same time at the same rate because of the pressurization. And I kind of describe it because I'm often talking to HVAC mechanics, and I'm a former HVAC mechanic. It's like an orifice on an old air conditioner, right? It reduces the pressure. Are you an AC guy?
No, but when he said the orifice flashes, the liquid can flash to gas. I mean, what happens in an evaporator coil, right?
Exactly what happens in an evaporator coil, right? So
yeah, it's the same exact thing.
But for an old orifice system to work, you need the head pressure to be right, correct? So
sure.
Head pressure in our world is gallons per minute, 40 to 85, and I think it's 85 PSI max. Keep it over the 40. This is why, I get calls occasionally if people were to pump oil, transfer oil into our tanks that they treated, and we can talk about that too. But the expansion kit's got to be pressure filled, okay? Which means that if they just take like a teal pump that might pump 10 gallons per minute, put that in the hole outside, the tanks won't fill equally because it's not under pressure.
You'll fill the first tank, but not the second.
You'll fill the first tank. The oil's going to take the path of least resistance, and they'll be all unequal. So, just to add on to.
Thank you. Actually, a couple more follow-up questions in the same vein. We talk about pumping. A lot of tank failures. Guys will take the fuel, pump it into a transfer tank or storage tank, and then put it into the new tank, which is generally frowned upon. Does Roth have a policy on pumping? People call it pumping over.
Yes, we do have a policy, and our policy is that it doesn't affect the tank in any way. So it doesn't affect our warranty in any way. But what confuses people, and I understand their confusion, is that on the label on our tank, it says do not fill this tank with oil from the old tank. And I'm paraphrasing a little bit. So people look at that and say, well, it must be to avoid the warranty. Well, it won't. And so then the question is, well, why do you put it there if it won't void the warranty? And the answer to that question is because UL says so. Their marking requirements for UL 2258, which is the standard the tank is listed to, requires that statement be on the markings on the tank. So we don't put it there because Roth wants to. We put it there because UL says you shall do this if you want a listed product.
That answers the question. Got another follow-up question on multi-tank installations from it's a little slow loading up. Also from Steve Martino. On multi-tank installations, couldn't a small vacuum leak cause the tanks to draw differently, resulting in one tank having slightly more fuel in it than the others? Then subsequent filling using fuel may result in one tank eventually getting overfilled. I'm assuming he's talking about on the suction side, the supply side to the burners or burners.
Yeah, yep. Well, we advocate that people use pickup lines, say in a two-tank system. They use two pickup lines or suction lines that are the same distance off the bottom of the tank. They're the same length, and they tie together at equal lengths from the top of the tank to the T, basically. And to answer that question, we have seen situations where we believe a little bit of air infiltration into the line can create an unequal draw. But typically, if there's any significant amount of air infiltration into the fuel line system, at some point in time, the burner's not going to start. You're going to have airlock or the ill effects of air at the orifice in the burner. So that's not a frequent situation. It's a possibility, but not one that we see terribly often.
But also, can you touch on the fact that the dip tubes will equalize the tank? So if the tanks end up being unequal due to being filled wrong or due to having a vacuum leak or something like that.
This is where I get to use my favorite analogy, and that is two beer glasses.
Yes.
So you put two beer glasses on the table, and you fill one of them 3/4 full, and you fill the second one 1/4 full, and you get somebody to manufacture for you a glass straw in a U shape. So you can stick the legs of that glass straw in each glass, but there's also a port at the top of the U that allows you to draw the air out of that space in the straw so that you've created a siphon. And once you get the air drawn out of there, this thing we call gravity will create a difference in head pressure at the bottom ends of the straw in each glass. And the beer will run out of the glass that's 3/4 full into the glass that's 1/4 full until they're both half full. And that's basically the principle we have here. In a residential heating system fuel line network, once you purge it and get the air out of it, you've created a closed siphon between the two tanks. So if there's more oil in one tank or a greater level of oil in one tank than the other, then given some time, they will equalize through the fuel line.
Thank you. I have another question from Sean Hiscock. Thanks, Sean. And the question is, any policy on using additives like fuel conditioner?
Absolutely fine.
There really isn't for us. To evaluate each of the products that's out there would be exhaustive for us. And one of the things that we share with people is if you're buying a fuel additive in some sort of a single-use container, what is the single-use container made out of? So you flip it over and read the bottom, and it's either Teflon or polyethylene, and the tank is made out of polyethylene. So if whatever you're putting in the tank isn't eating the bottle that it's shipped in and packaged in, it's not going to eat the tank. And the other thing is, typically you're adding a quart or a couple of pints or some small quantity to a significant volume of oil, and there's no, there's such dilution that there's no deleterious effects. And we have never seen any evidence that additives cause a problem. So we don't have any restrictions on it, but at the same time, we don't maintain any approvals. You can use this one, but not that one, et cetera.
Biofuels, biodiesel, renewable diesel, 100?
The Roth tanks are approved. The original approval from UL was fuels up to, I think it was B20, and then all the way to B100. And that's been revised at this point so that it basically includes all bio blends from B0 to B100. So in terms of reactivity with the polyethylene, we started doing permeation testing on B100 in 2012 with UL to test the resins and the manufacturing process to make sure that that the tank was compatible. And to date, we haven't had any issue with biofuels, biodiesel, but we've also had people experiment with it on B100. Probably half a dozen years ago, I was working with, doing some work with John Levy, who you guys have probably heard of.
Sure.
And he was doing some small scale testing on systems, not only tanks, I think, but other system components with B100. And the one issue that he ran into as they were testing fuels and evaluating fuels is, at that point, I can't speak for what it is now, excuse me, but at that point, B100 had a cloud point or gel point of like 40 to 42 degrees F. And in Syracuse, 40 to 42 degrees F shows up in late September, early October. So we're not even,
next week.
We're not even winter. It was 68. No, I'm sorry. It was 59 when I left the house this morning. That's how cold it was.
Oh, wow. Already?
Yeah. We've had some cool nights and some nice warm days, really pretty summer weather. But at any rate.
It was actually 55 this morning.
Really? Yeah. So
even colder than Syracuse. Yeah, it was chilly this morning.
So as we move forward and continue to elevate the biological constituent in blended fuels, that fraction of the fuel that's biomaterial, my understanding is we're going to see gel points or cloud points increase with the content. So it'll be an interesting situation to address with fuel storage, and especially outdoor fuel storage. So.
Yeah, I mean, NORA's doing a ton of research on that. Obviously, we're doing some stuff up near Syracuse and Morrisville, New York, and we're going to hopefully kick off one in Troy, New York, and we're doing a bunch of it with SEMA, too, in northern Connecticut. Not quite as cold, but it's a major topic, and that's why I think the additives, there's a lot of potential solutions for that problem.
Yeah.
But there's 450,000 or so tanks outside right now. Yeah. So it's obviously a problem that needs to be addressed.
I remember John asked me to look at what it would be to insulate an outdoor tank with some sort of flexible blanket with pad heaters against the steel outer tank on the inside. And he said, "Do you have any idea?" And I said, "No, but I'll do some poking around and see what I come up with." And I went to three different manufacturers of flexible insulation, like the fabric jackets with either a rock wool or a chopped fiberglass media, and a couple of the surface type heating elements and whatnot. I think the whole package for a 275-gallon tank was about $3,500. Now that was for one, so economies of scale are going to have an influence on that. But even if it's half or a third of that to insulate a tank, it's going to add a lot of cost to this. So it's be interesting to see what happens.
That solution may be prohibitive. The chemical solution is obviously the preferred, and the cloud points now are down around 30F, 32F, 0C Celsius. So they've gotten a lot better, and it depends on the feedstock the biodiesel is made from.
Yeah. Yep.
There's still a lot of.
Yeah, in qualification of the comments that I made about 40 and 42 degrees, John, I think, was working with a small batch of fuel that, was kind of home brewed, single barrel type thing. And I assume no additives or treatments in it, but just the raw fuel. So I'm sure there's things that have been worked on by a lot.
It's gotten a lot better, but still, I mean, 30F is a problem also. So initially right now, New York and Connecticut are on B10, Rhode Island's on B20, and in 2035, they're going to go to B50. Well, Connecticut and Rhode Island anyway. And Connecticut is going to go to B20 in 2030. So, I mean, the numbers are going up, but we're still quite a ways from B100, so there's some time to solve this problem.
But the key takeaway is the Roth tank can handle B100.
From a materials.
Actually, anecdotally, the Roth tank is somewhat better. The polyethylene is a lot less thermally conductive than steel. Yeah. And you guys have the advantage of that little interstitial space there.
The airspace gives you R value, right? And it's plastic, not metal. So it's not thermally conductive, and you get R value with that airspace. So,
you get a little more time before the bad stuff happens.
Yeah.
and hopefully the sun comes up by then. Steve has obviously been able to join us, so now he's asking his questions himself. And his next question is, would it be a good idea for indoor tanks to put a small sign at the fill saying a Roth tank is installed and requires a constant pressure fill of at least 40 PSI? I think it's 40 GPM.
It's 40 GPM, yeah. But our expansion kit already comes with a little sticker to put on the fill pipe indicating that there's twinned Roth tanks inside. We don't put a GPM rating on it. I mean, it's not a bad idea, and not a bad idea at all.
I think it advises you to fill the tank at a fast fill setting, which basically addresses that.
Yeah.
But it doesn't identify a specific number?
No.
I don't think so. No.
That almost seems like, I mean, it's great that you took the lengths of creating that. Yeah. But it's almost like it's missing that piece of information.
Fast fill can vary depending on the truck. I mean, from the people who I speak with, fast fill can be anywhere between 65 and 75. So I think as long as we tell folks to fast fill it and don't throttle it down at the nozzle, that's probably enough. And this gets back to reading the book. Okay, it's clearly stated in the book, the 40 gallons per minute. So we're back to RTFM.
Oh, okay. So it is in the book.
It is.
Okay.
Yeah, it's in the instructions.
Yeah.
So being top drawn, do you think there should be fuel polishing? I think what he's getting at is that the fuel below the pickup line is sitting there all the time, although that happens in any tank that you're top drawing. Or maybe because you guys don't have a drain at the bottom.
Yeah, I'm not sure. That's something I'm not familiar with at all, so I can't.
Me too. I'm glad you said that, Bruce. Yeah.
What fuel polishing is? It's common in marine markets and other markets. So basically, they'll hook up a pump to the tank and pump the fuel through a filtering system, a treatment system, and then put it back into the tank. So it's like cleaning, vacuum cleaning the house. Very similar to that. It's NORA's done some research.
It's what you should do when you're pumping over, basically.
Yeah, you shouldn't pump over, but if you...
But
you shouldn't drink, but if you're going to drink, don't drive.
I'll add on to that, too. Like, I'm an old oil guy, right? And we used to, long time ago, back when oil was cheap, keep the dip tube 3, 4, 5 inches off the bottom just because of sludge formation, okay? With the Roth tank, since we don't rust or corrode like other materials, the opportunity for sludge to gather at the bottom of the tank is greatly diminished, meaning that you can bring your dip tube down much further than you might have otherwise with other tanks. So there isn't really much oil left that's being untouched. Now, Roth doesn't tell you how far to keep your dip tube. Guys ask me all the time, half inch, that's up to the installing contractor.
Yeah.
But you don't need to keep it inches off like you used to when fuel was poor quality and dirty and all that kind of stuff. Fuel is much cleaner now, and you can bring your dip tube lower into the tank than you used to. So there's less oil left on the table, as it were. You know what I mean?
Yeah.
We get the question from time to time, how do I clean this tank? You know, if I get a bunch of sludge in it, how do I clean it? Well, obviously all you have to work with are the top connections to get a wet or dry vac with some sort of a special snorkel or whatever into the bottom of the tank. But we've had a few tanks that have come back to us that we've asked for to basically evaluate, that have been in service for 15, 17 years. And we cut them open, and any of these few, and it's a very small sample, probably less than half a dozen, 6, 8 maybe, I haven't seen more than a teaspoon or a teaspoon and a half of crap in the bottom of the tank. So, I mean, even if you're running it an inch or an inch and a half off the bottom, the likelihood of actually contaminating a filter or causing a dirt pickup problem with the fuel system is pretty small.
Yeah, Steve had a follow-up comment that it's big on diesel generators or fuel sits for months or years.
Yeah,
that makes sense.
Common,
Agreed.
you know, hospitals, fire departments, schools where they have backup generators, it's really common to have them do it every, 6 months or even more often. Steve's got more questions. Oh, let me show it. No, wrong one. There we go. Use mega press and the proper sealing element. So you guys are okay with mega press?
We are. I did a fairly in-depth evaluation of those. The concern that we had in terms of using MegaPress on fills and vents is basically making sure that, like the swing joints, you allow for some flexibility in the piping geometry after the tank is installed. So if you get a little bit of settlement when the first fill takes place, which can happen, usually we're talking 3/16 of an inch, so it's not an awful lot of displacement, but that little bit of flexibility that a swing joint will provide you gives you the chance to realign piping. So when people were asking us about MegaPress, our concern was that we might lose that flexibility. Excuse me. So I actually looked at some of them, got my hands on some of them, and talked to Vieta, I think it was, who was the manufacturer involved in the ones that I was talking about. And there seemed to be the ability to rotate the piping within the MegaPress coupling and not inhibit that. So we don't have any, at this point in time, we don't have any restrictions or concerns about that. We approve it. We always caution people that changing pipe fittings or doing anything non-conventional with pipe fittings that's not NFPA referenced or whatever is subject to the authority of local jurisdictions. So you may run across, a building inspector in some particular locality that walks in and looks at those MegaPress fittings and says, "Not here, you don't," and out they go. So yeah. That's the only thing we're concerned about, is having somebody check that beforehand. Excuse me.
Authority having jurisdiction.
Yeah.
Which is usually local.
Yeah. Yeah.
It always is. NFPA approves it, but that doesn't mean the local guys do.
Yep.
Another question from Steve by proxy, and I'm going to translate this. I think it means, would you approve the use of copper press-on tanks, which NFPA 31 does not allow copper on fill and vents? So
yes. I think NFPA, the language in NFPA 31 is centered around black iron. Somewhere in New England, and I can't remember where, Rhode Island or Eastern Connecticut or whatever, there are some locations that allow copper, and I've seen tanks installed with copper fill and vents.
I am sitting in one of them right now.
Oh, okay.
and we don't need no stinking NFPA 31.
From Roth's perspective, we don't want to see galvanized pipe because the fuel will react with the zinc and the galvanized, and it'll all wind up in the burner. So if you're not going to use black iron pipe, we've never come out and said you can't use copper. But we caution people, if you have a desire to use copper, that you check and make sure that you're not going to have to tear it out.
Yeah, I mean, NFPA 31 doesn't allow it, so that's probably, even if your locality allows it, God forbid there's ever an issue, if you follow NFPA 31, you have a pretty good defense.
Yeah.
To rest on. So that's the kind of, even though it was allowed here, I never used it. I always went with NFP 31 just to be on the safe side. And related question, I've talked to a lot of people who have huge, strong feelings on where the thing should be located on the top of the tank. You can't put the fill next to the fill and vice versa. And there's a limited amount of spots. Is there any official policy on that?
I missed some of your question, Robert, because we were having some delay.
I'm a little glitch there. Sorry. The question is location of fill, pickup, and gauge. Some guys have some strong feelings. They feel that the gauge gets wrapped around the pickup tube. And
we talked about this in our training class, Bob. So yeah, don't put the gauge next to the duplex bushing because the float can wrap around the dip tube. But the 4 bungs on top of the Roth tank, there's no designations for uses, right? The 4 holes on the top can all be site-specific, but the only caveat we really make is we recommend not putting the gauge next to your duplex because the float can, if your tank's empty or swirling around during a fill, hook onto your dip tube. You know, customers still going to have heat, but the gauge won't move, and they're going to be blissfully unaware that they're burning oil despite the fact that their gauge isn't showing it.
Yep.
Thank you. Another one, a lot of guys, I haven't seen this in a while, but a lot of guys on Long Island would use a 2-inch dip tube on the inside of the fill. They thought that the fuel moving around the tank caused that. And it's very common here to see they'll use a 2x24 nipple on the bottom of the fill fitting.
Yep. No reason not to. I mean, it does. I can certainly see how it would reduce the agitation in the tank. So there's no problem doing that. And all the adapters, the metallic adapters that we provide are double threaded. So they have a tapered pipe thread in the bottom as well as the top. So you can do that.
Yeah, it's quite common. With NORA, we take a lot of fuel samples from tanks and pull them out and run into that situation where there's a 2x24 nipple on the bottom of the fill. Quite common. Yeah. Steve's loaded with questions. He's got yet another one. Copper versus steel pipe dip tube, or maybe stainless steel. The comments are usually about how the biofuel breaks down the copper, so steel is better. I'm going to jump in and correct that. It's actually the other way around. The copper attacks the fuel, not the fuel attacking the copper. Yet to me, everyone's main reason to move away from steel tanks is the fuel attacking the steel. Doesn't it attack steel? So biodiesel and heating oil and renewable diesel aren't corrosive in and of themselves. It's the moisture and the acid that gets into it that it can be. So the steel dip tube sees them along in the wrong direction, eventually into an issue. Also, if I recall, the initial report about copper and yellow metals concludes basically in residential use it's not an issue. So I guess the question is, what should you use as a dip tube?
We're talking about the fuel pickup tube, basically.
Yeah,
right?
the pickup tube. Yeah, should you use?
We've never run across anybody that's had an issue with just using copper. There is certainly no reason why you couldn't use stainless. There's no compatibility issues with the tank or the proximate materials or whatever in the tank. So you could certainly use stainless steel if you desired to.
And you can also use, since our duplex is double threaded, like Bruce said, all of our fittings on top are double threaded. You can screw a big piece of black nipple to the bottom of the duplex, have that be your dip tube, or have that be a piece of conduit to push your 3/8 copper line through, you know. So we don't really have a horse in that race as far as what the material. I mean, most people just use the slip-through fitting that comes with the duplex and just push copper down, or a lot of guys also just use a big long black iron nipple or a piece of hard copper with a male adapter sweat on it screwed to the bottom of the duplex.
I've seen that done a few times.
Yeah. I remember
all
years
those are
ago,
quite.
I was going to say years ago, I remember guys taught me that they referred to those as a spare. They said, you want to have a spare in the tank. You don't want to run the line because you risk when you're feeding it down, it might bend up. If you just put a piece of black iron and screw it, you can't go wrong.
Yeah.
And then you know how far you're in there.
Yeah.
You know what I mean? Because you pre-measure.
No question.
So it's a definite thing. Yeah.
Yep. Actually, it's another one with the Roth. You do see a lot of tanks here with they're going 3-4 inches above the bottom. And I think a lot of people lose sight that the tank is more vertical than horizontal. So they're going, 3 or 4 inches that tank is less fuel than in your guy's tank. You're leaving more unused fuel sitting there when you go 4 inches off the bottom in a vertical tank. I actually had a customer ask me this years ago. She wanted 275, wanted to go with the Roth for the space savings, but do they make a smaller 275 tank dimensionally? And I'm like, well, it's 275, so it's got to be those dimensions or some variation, that cubic volume. And we just went around in circles. She just wasn't. She's like, you're not understanding what I'm saying. You're not, you got to look harder. I'm sure they're out there. I'm like, lady, I think I could look as long as I wanted to, and that's not going to happen.
We could make one 12 inches square and 12 feet tall, if that's what you want.
Yeah, there you go.
We do have the 1000 LH tank, which is a 275 of a slightly different
lower
geometry, right? 7 inches shorter than the 1000 L. So a little shorter, a little deeper, little fatter. So the width goes from 28 to 30. The depth is more, but the height drops down for scenarios where you might want to reuse a vent and fill holes that go outside. I mean, who wants to core new holes in the side of a house, right? So sell the LH tank in scenarios like that, and you can also sell the LH tank outside because we do sometimes get complaints. It's hard for the drivers of the pump truck to reach the scully fill, right? Sell an LH tank outside in that scenario. A little shorter.
That's the issue on a 400.
Yeah.
No, it certainly is.
We sell step ladders with 400.
Yeah, I'm 6'4", and it's touch and go. So you got to be 6'5", 6'6" to be able to do that.
I'm not even going to comment.
Roth collapsible ladder.
You just told us all we need to know, Alan.
That's right.
Oh, thank you. I had a question. I forgot it now. Anyway, let me take the opportunity to thank you guys. In addition to my position at NORA, I'm also the president of OESP, and I'm on the board of directors of Oil Heat Cares. And I just want to thank Roth for their generosity supporting Oil Heat Cares. Continual, absolute, all the time. You guys are just incredibly generous in supporting Oil Heat Cares and helping people out who are needy and are up against it. And just want to take the opportunity to thank you guys. It's greatly appreciated.
Amen.
Thank you for the recognition. It's an honor to be part of it.
It's a great industry from a people's standpoint, especially to be involved with. It's great.
It is. And I guess I also have to mention that Roth is the 2026 OESP Manufacturer of the Year.
Yeah.
Again, very well deserved.
Dan, you must have done something right.
Yeah.
Don't let that get around. It's been a very good year. But it's so nice to see, like I see the articles of everyone pulls together, the contractors, the wholesalers provide the trim, boiler manufacturer provide the boiler, Roth provides the tank, and it's just a thing of beauty watching everyone kind of pull together to help the less fortunate.
Yeah.
It's really nice. It's nice to be a part of it.
A couple of weeks ago here on Long Island, thanks to you guys. It's greatly appreciated.
We didn't touch on quick synopsis of the features and benefits of the Roth tank, right? Obviously, it's double-walled protection, so it's a seamless inner tank. Okay, and I always concentrate on the word seamless because seams fail. Okay, welds can fail, anything like that. So seamless inner tank, housed inside of a secondary containment galvanized steel dike, holding 110% of the capacity of the tank size, takes up a lot less space in the basement. Okay, it's 8 square feet it inhabits in the basement, which means that homeowners gain a little real estate compared to other tanks. 30-year part warranty and a $2 million insurance plan. Used to be $1 million. Now, so if a tank fails out in the field, whether it's outside or inside, due to workmanship on our part, Roth will help with the pollution mitigation. So we're very proud of that, and it's unique to us.
There's another factor to touch on too. NFPA in the 2020, I believe, edition, or the 24, requires outside tanks that are top draw be double walled or have containment. So a lot of people put in conventional tanks outside that don't meet that requirement. And a lot of times it happens, you'll have an outside tank. They go there last February when it's -4, it's gelled, they switch it to a top feed. They just created that code violation.
Yeah.
So that's where NFPA requires double walled or containment for top feed tanks outside. So
the rule you're referring to was as of the 2020 printing of the book.
That's
We're
correct.
aware of it. Yeah, and it states that the tank be installed inside of a secondary basin, but that holds 110% of
the
volume
capacity
of the tank, which our tank already does. So
Right.
yeah, but that's worthy of note. Absolutely, thanks for bringing that up.
That's real important, and a lot of people don't realize that. And they create they didn't know it, they didn't know on purpose, but they go to a tank that's gelled. It's a bottom feed. They got to get it going. It's, Super Bowl Sunday, which was this year was -2 or 3 here, and they put it on a top feed, and it's not a double wall, and it's not in containment. So if there's a problem, they're going to be on the hook for that.
That's
So
right.
be aware of. So if there's nothing else, we can call it an evening. I don't see any more questions.
All right.
Yep. Thank you, everybody, and thank you, Dan and Bruce, for joining us.
Thank
All
you
right,
both for inviting
Have
us.
a great weekend. Thanks again for the opportunity.
Thanks, guys.